A unique and challenging lift took place off the coast of San Diego, California in January of 1995. A few months before, a United States Navy F14 Tomcat fighter jet was unable to complete the landing approach to an aircraft carrier. The pilot ejected too late to be saved, and the jet sank into 3,800 feet of water. Water this deep had prevented recoveries before. Twice before, the recovery lift of this jet had failed. Now, armed with twin-path extra lifting slings made with K-spec high-performance fibers, the Navy's deep submergence unit was going to try again. These slings are almost neutrally buoyant for ease of rigging by a robot lowered to where the jet lay on the ocean bottom. The slings were fabricated with very short lead time. The Navy called SlingMax dealer BC Wire Rope of Anaheim, California, on a Friday afternoon for a lift on Sunday that weekend. The two slings used in the lift are 48 feet long, with vertical rated capacities of 85,000 pounds each. At operational weight, the jet is a 45,000-pound load, but the water weight from being submerged is a major factor and figured heavily in the failure of the first two attempts. If this recovery was to be successful, the slings would have to be rigged properly. Part of the rigging problem was being able to see the slings on video in the murky depths of the ocean. The sling jackets are made of abrasion-resistant bulk nylon. To enable them to show up better on video, BC made special wear sleeves that were lined with reflective material. These reflective sleeves permit the robot to make the correct sling hitch in the right location on the badly damaged jet. On board the command vessel with its crane, the operators manipulate the robot via video transmissions to place the slings around critical points on the fuselage. With the jet rigged for the lift, the hoist reels in the line. The lift to the surface goes smoothly, but the operation stops with the jet just under the water. The transition out of the water is critical. Just above the water's surface, no longer to be supported by the relatively high density of the seawater, the jet is filled with water, adding a tremendous amount of weight. As the water drains from the jet, the center of gravity will be changing constantly until the jet is completely free of water. On a previous attempt, this was a critical point in the lift. The slings are connected to the crane hook. The jet exits the ocean water without any problems. Dripping seawater, fuel, and lubricant, the jet is carefully placed on deck. Then the jet is repositioned for stability on the barge and hosed down for safety. The lift is completed successfully. The jet is recovered. The barge is towed into the carrier pier at the North Island Naval Air Station in San Diego. The same slings used for the lift from the ocean bottom are again used, this time for transferring the jet from the barge to a flatbed trailer on shore. The jet will then be taken to a location where it will be thoroughly examined. The lightweight, flexibility, and almost neutral buoyancy of twin-path extra slings with high-performance fibers made this lift possible. The successful recovery of this jet led the Navy to recover 3 other fighter jets that were lost in deep water. BC Wire Rope received a special commendation from the U.S. Navy for a job well done. Twin-path slings with high-performance fibers do the tough jobs.